Okay, so what we're learning in this video is what we started this chapter with, how to count by mass, but this time we're moving into actual chemical compounds. And in order to do that, we need to revisit the periodic table again. So remember that on the periodic table, there was the atomic number, and we've been using that a lot over the past few months as the number of protons or the number of electrons in a neutral atom. And then, of course, we have the symbol and the name, and then we had this number down here, which was the average atomic mass. And remember, the average atomic mass was the average mass of one atom, and the unit for that was an AMU. So when we learned this, we learned that oxygen has an average atomic mass of 15.99 AMU. So one atom of oxygen weighs approximately that amount. What we have learned, or what we're going to learn, is that that number can also be known as something else. That number can also be known as a molar mass. So that is that number right there as well. Molar mass is the mass in grams of 1 mole of any pure substance. That's why Avogadro's number is such a weird number, because we needed this number on the periodic table to stand for two things. It stands for the mass of one atom if we make the unit atomic mass units. It stands for the mass of 1 mole of those atoms if we make the unit grams. So for example, if you look on the periodic table under copper, the average atomic mass for copper is 63.55, or 63.55 grams is the mass of 1 mole of copper atoms. So 6.022 times 10 to the 23rd copper atoms has a mass of 63.55 grams. And we can use that in our conversions just as we have been doing all along. So how many grams, circle the do, of lead is 0.900 moles of lead. So we take that number and we put it out front, 0.900 moles of lead. And now our conversion factors are going to be from the periodic table. They're always going to be 1 mole is equal to, and then whatever the number we get from the periodic table in grams. So we look at lead on the periodic table. Lead is a transition metal. Lead's right here. And so it's 207.2. So that means 1 mole of lead will have a mass of 207.2 grams. And this is what I plug into my calculator. 0.900 times 207.2 divided by 1, which we don't have to put the divided by 1 in. And my calculator gives me 186.48 grams. Now, this is where we do need to worry about significant figures here. This number was measured and it has 3 significant figures. Any number coming off the periodic table has 4. We're just going to make that a blanket statement and use that for the rest of the year. Remember, the 1 mole doesn't matter. So I'm going to round this to 3 significant figures, or 186 grams of lead. So 186 grams of lead is 0.900 moles of lead. A sample of tungsten has a mass of 103.5 grams. How many moles of tungsten are in the sample? So we take the number that's given to us, 103.5 grams of tungsten, and we convert it over to moles. Remember, whatever we're converting to is on the top, and we're using the same conversion factor, that 1 mole is equal to the periodic table number of grams. So now if we take a look at tungsten is over here, number 74. So the molar mass of tungsten is 183.8 grams. So I take 103.5 divided by 183.8 grams. And again, thinking about significant figures, I get 0.563112, but to 4 significant figures, it's 0.5631 And again, that's going to be moles of tungsten. I didn't do this on the last one, but whatever unit up top is the same as the unit down bottom so that the units cancel. So grams of tungsten and grams of tungsten on the bottom, the units will cancel. Now we just did that for two atoms, two elements, tungsten and lead, but most of the time in chemistry we're working with compounds. So now let's take that problem, let's take that idea and make it into compounds. So we just add up the molar masses of the particular elements. So for example, if I want to find what is the mass of 1 mole of NaCl, 1 mole of 6.022 times 10 to the 23rd formula units of NaCl, I just add up the sodium. This is actually, these two are backwards. The chlorine is 35.45 and the sodium is 22.998. And you add that up, and that's the molar mass of the compound NaCl. You can see the units here, grams/mole, because what that means is 58.4425 grams would be equal to 1 mole of salt. You can see the same thing is done with water over there. You add up 1 oxygen and 2 hydrogen, and you get 18.0153 grams per mole, or grams of water equals 1 mole of water. Here's another example with a compound called paradichlorobenzene. Paradichlorobenzene is 6 carbon atoms, 4 hydrogen atoms, and 2 chlorine atoms. So if we add up the 2 moles of chlorine, the 4 moles of hydrogen, and the 6 moles of carbon, we'll get the molar mass for that. And just so, just as a reminder, these are, similarly, this is a giant amount of moles, right? 6.022 times 10 to the 23rd, 1 mole is that many molecules of paradichlorobenzene. Paradichlorobenzene is the active ingredient in mothballs. It's actually not that much of that compound. So we have 2 problems here, the molar mass of carbon dioxide and the molar mass of copper 2 phosphate. So the molar mass of carbon dioxide, I just write out the 2 elements, carbon and oxygen, how many of each there are, and then multiply them by the numbers on the periodic table. And so 1 times 12.01 is 12.01. And this is 32.00, and then I add them up to get 44.01 grams. What does that mean? 44.01 grams of CO2 is equal to 1 mole of CO2 atoms, meaning like 6.022 times 10 to the 23rd atoms. And for copper 2 phosphate, I just want to, this is a little bit more complicated, you should be really careful about how many of each element you have, because especially with polyatomic ions, we need to remember that that outside subscript is going to be a multiplier. So in this case, there's 3 copper, there's 2 phosphorus, and there's 2 times 4 or 8 oxygen. Copper is 63.55 grams, and it will take you a little while to learn where all of these elements are. This is really the first time that you're going to be looking up a whole bunch of different elements. Now, when I do this out, I made a nice little table like that. Honestly, I just do most of it in my calculator. So in my calculator, I'm plugging in 3 times 63.55 plus. You don't have to break this out into numerous calculations. So I just do this all in once on my calculator, and I got 380.59 grams of Cu3PO4-2. And then the last molar mass question, what is the molar mass of C12H22O11? This is the chemical sucrose. So try this one on your own. Okay, so try it out. See if you can get 12 times the carbon, 22 times the hydrogen, and 11 times the oxygen, and then add them up. Your answer should come out to be 342.296. Okay, show your work. If you don't get that answer, we'll go over it in class the next time I see you, or you can ask me a question about it.